All right, guys, so I'm just going to run through and do these. This is the Chapter 3, Part 1 review. So the first part is 1 to 17 every other odd, starting with number 1. So this first section, we are computing the average rate of change. So it gives us a function down in Figure 1. And so what they want is the average rate of change from 0 to 2. So let me actually put that picture. So average rate of change, what you can think of that as is the slope of a secant line. So from 0 to 2, this is literally like Algebra 1 stuff. Like you pick points off the graph and then calculate the slope, which is also known as the average rate of change. So here's a coordinate point 0, 1, and then at 2, there's a coordinate point 2, 7. So literally what we're doing is taking those points. So you have a coordinate point at 0, 1, and then you have a coordinate point at 2, 7. Classic algebra stuff, change in y over change in x. So we've got 7 minus 1 over 2 minus 0. So 6 over 2 gives us an average rate of change of 3. And when it asks for the graphical interpretation, like I said, that's the slope of the secant line. So that's what we just found there, was the secant line from point to point and what its slope was. So the next every other odd would be 5. And for this one, we are doing the limit definition. Make sure you know how to do this because you will still need to do this on the test. So our function is x squared minus x, and I know this might be a little painful now that you know the easy way, but for the AP test, it's still important to know how this definition works. So we had a 4-step process. Step 1 was to find f of a plus h. So here, let me write out what our actual, in case we forgot what this was. Okay, so like that. So we have a 4-step process. Step 1, step 2, step 3, and then step 4 was to take the limit. So first we want f of 1 plus h. So that means we're taking my function, plugging in a 1 plus h, and then kind of simplifying algebraically as much as we can. So this requires foiling, 1 plus h, 1 plus h. So that'll turn out like this, and then be careful. Make sure you're subtracting both of those pieces. So the 1's will cancel, which is good. And then 2h minus h, and then there's an h squared. Okay, so that's my step 2. That's step 1, and then step 2, I take what I left off with in step 2, because that's this piece right here, and then subtract f of a. So f of a is what I get when I plug 1 in here. So 1 squared is 1, minus 1, and that just ends up being 0. Remember what I've said at the end of this step, there shouldn't be anything that doesn't have an h in there. So that's nice. These cancel out, and I'm still just left with this. This is not typical. It's not typical that step 1 and step 2 have the same thing, so don't decide that that's like a shortcut. The only reason that happened here is because f of a was 0, so we weren't subtracting anything. Step 3, remember we take what we left off with in step 2, which is the numerator here, and then finish off the quotient by dividing by h. Reduce that down, I get a 1 plus h. So that represents the slope of the secant line between 1 and 1 plus h. So now, finally, I do step 4, and I take the limit as h approaches 0 of that expression. And so I wasn't able to take the limit up here because I would have a 0 in the denominator, but after all the simplifying, here I can just sub the 0 right in. And so I end up with 1. Okay, what they're asking for next is the tangent line, now that we have that. So this is an important reminder right here. Here's point slope form, which you guys are going to use for your tangent lines, and you can just leave it there. So y minus, in order to find the y value, you take what they give you and you plug it into the original function. So we plug that in. We know from one of our steps that we get 0. And then m is the slope at that point, so that's 1. And then x minus, and they always give you the x value. So this is just y. If we distribute that 1, which doesn't do anything, we get x minus 1. So that is our tangent line. All right, next every other odd jumps us to 9. Okay, so then we are again using the limit definition to compute something in there. So we've got y equals 4 minus x squared. This time the directions are asking us to find the actual derivative. So when we're finding the derivative and not just the derivative at a point, it'll slightly adjust this formula to use x's instead of a's. because a's were one specific x value. Here we're just generically going to use an x so that we end up with a function at the end instead of a number. So I have the same four-step process. I'm going to find f of x plus h. So plug that into this function, 4 minus x plus h quantity squared. So be careful with the subtraction. I'm going to write the FOILing first in parentheses. And then you can carefully subtract. So we subtract every single one of those pieces, which means they're all going to end up negative. Careful with signs. They can throw your whole problem off. So step 2, we take this, so exactly what we left off with in step 1, and then subtract the original function f of x. So I'm going to subtract this quantity. And then remember what I set up above. At the end of this step, every single term that you have should have a factor of h in it. So 4 minus 4 will cancel, and then I have negative x squared minus negative x squared. So those will also cancel. And I just have 2 terms left, and they do both have a factor of h. So that means I'm good to move on to step 3. Step 3, I take what I left off with from step 2 and finish off the quotient. So negative 2xh minus h squared. Divide by h and reduce everything down. So I get a negative 2x minus h, and again, that represents the slope of my secant line. And finally, with step 4, I am going to take the limit as h approaches 0. Okay, and again, at this point, I can just plug the h right in. H is 0, and that leaves me with a negative 2x. So now that you guys know how to do these by hand, you should be able to kind of confirm that yes, your answer should be a negative 2x by using the power rule. So you can write y prime, that's our derivative notation, equals negative 2x. So that's a derivative function rather than just the derivative at a specific point. Okay, next, every other odd would be 13. This is asking us to express the limit as a derivative. So let me write down exactly what we have here. And this is why it's super important to still know that limit definition, because the AP test loves asking this question. It'll give you something that just looks like this super weird quotient, but they actually want you to figure out what the function is, what you're trying to take the derivative of. So remember, it's supposed to be like, this is your generic form. I had this written up above. Okay, so f of a plus h, because what we really need to figure out is what function are they trying to get us to take the derivative of, and at what point. Okay, so f of a plus h, it's pretty clear that a is 1. So, because this a plus h is written as 1 plus h here. So the point they're trying to get us to find the derivative at would be a 1. And then 1 plus h was plugged into some function. What was that function? Well, it appears to be the square root of x. So if we take this function and plug that stuff into this formula, you can see that what we're going to come up with is this. So f of 1 plus h, if I plug a 1 plus h in here, I get this, minus f of a. If I plug a 1 into this function, I get 1, and then of course the h is just part of the formula. So they are asking us to find the derivative of this. I'm not entirely sure if they actually want us to find the derivative. I suppose we could, using a power rule. So this is x to the 1/2, and that allows us to use the power rule. And so f prime, remember the 1/2 comes out front, and then our old power, you subtract 1 from it to get the new power. So that's the derivative that they're looking for. The derivative at 1, I could just plug that right in. And of course, 1 to any power is still 1, so then times 1/2 would leave me with 1/2. So what that means is if I were to take this and simplify it down algebraically, which would require a lot of work, I would end up with 1/2. Okay, next we move on to 17. Okay, and 17 is asking us to find f of 4 and f prime of 4. It gives us an equation, and then we are finding the tangent line. So the equation is y equals 3x minus 14, and it asks us to find f of 4 and f prime of 4. So it gives us x equals 4. We find f of 4 by just plugging into the original function, so just right in here. Okay, so the y value, when x is 4, the y value is negative 2. And then it asks us to find f prime of 4. You can't find f prime at a value until you find f prime in general, if you're doing the quick derivative rules anyway. So the derivative of this derivative of 3x, since it's just a linear piece, is just 3, minus, and then the derivative of 14, since it's a constant, would be 0. So my derivative is 3. We probably could have told ourselves that if we looked from the very beginning, because this is linear, and so derivative is the same as slope on just a linear function. So if f prime of x is always 3, that means f prime of 4 would be 3, since it's a constant derivative throughout its entire domain. So that's what I have so far. They're asking to find a tangent line, so we can plug into our point slope form right here. So y minus, the y value we found was -2, so this becomes +2, equals the slope, and then x minus the x value. Now, you can just leave it like this. I'm just going to go a step further just to show you something. So if I distribute this and then subtract this 2 from both sides, notice what I come up with is the exact equation that I started with from the beginning. So that's kind of a new little fact that you can add to your toolbox there. If you have just a linear equation, the tangent line to any point is just that exact same linear equation. Tangent lines are linear, so if the function itself starts off linear, it's not going to be any different of a function. Okay, 18 and 19, I can pretty much just show you guys the graph for. So we've got all these pictures. It says each graph shows a function and its derivative. Determine which is the function and which is the derivative. So just to tell you guys right here, remember our kind of like, cubic has a quadratic derivative. Quadratic has a linear derivative. Linear has a constant derivative, and constant functions have 0 as a derivative. So if you're looking at these two, I've got one quadratic piece, one linear piece. That means the quadratic is the original function, and then the linear piece is the derivative. Just to prove it to you though, notice how this function is increasing, then stops, and then decreasing. If we look at its derivative is positive, and then 0, and then negative. Increasing has a positive derivative, decreasing has a negative derivative, and if the function stops, then the derivative would be 0. And this is what I mean by stopping, having like a min or a max, a slope of 0. So A is f, B is f prime for this one. This one's a little bit different. It appears we've got two trig functions right here. So B looks like just a run-of-the-mill sine function, and A looks like a run-of-the-mill cosine function. So we know that the derivative of sine is cosine, and so if we say this is the original, that's sine, B, and then A is cosine, so that's the derivative. So here B is f, A is f prime. Let me just show you a couple features we should be looking out for. Notice that this max, the derivative has a point of 0 here, and this min, the derivative has a point of 0 here. Now, you might be saying like, oh, well, these are the same. Like here, A has min, max, min, and this function has zeros, but the increasing, decreasing behavior is actually opposite of what you need. So again, B is the original derivative. Notice it decreases, increases, decreases. As it's decreasing, A is negative. As it's increasing, A is positive, and as it's decreasing, A is negative again. If we kind of flipped them, let's say we thought this was the original function, A is increasing, its derivative should be positive, but this is negative. So that means B is not the derivative of A, it means A is the derivative of B. Okay, and then this one should be fairly straightforward using our rules with the exponents. B is clearly a cubic function, and A is clearly quadratic, so that means B is the original and A is the derivative. But again, some features to look out for. See how this has a local max right here, and this is on the x-axis. Then we've got a min right here, and this is right on the x-axis. And B goes from increasing to decreasing to increasing, and A is positive, negative, positive. All right, 19. Which one is the derivative? Okay. So again, the first thing you want to look for is the mins and maxes. So we've got a max somewhere in between -2 and -1. So the derivative should have a 0. So that one does, still in the running. That one does not, so B is out. And that one does. Okay, so it's either A or C. We've got a min between -1 and 0. So the derivative should have another x-intercept there. This one does, but it doesn't look like it's quite where we want it to be. This one's right in the middle, so C is looking pretty good, but let's look for like at least one more piece of evidence. This one has another max between 0 and 1, so I should have another 0 on my derivative. And this one does not. This one has a 0 at a, but this doesn't have a min or max. I'm sorry, this one has a 0. It doesn't look like it's quite where we want it to be. This one's right in the middle, so C is looking pretty good, but let's look for like at least one more piece of evidence. This one has another max between 0 and 1, so I should have another 0 on my derivative. And this one does not. This one has a 0 at a, but this doesn't have a min or max. I'm sorry, this one has a 0 at 0, and this does not have a min or max. So C is our winner here. So let's look for the behavior. Increasing, stopped, positive 0. Decreasing, stopped, negative 0. Increasing, stopped, positive 0. Decreasing, stopped, negative 0. Increasing, positive. Okay, so C would be the derivative for number 19. Okay, so I'm not actually going to write anything down here, so let's skip right to 23. The page. All right, 23. We've got a table, and the first thing it asks us is what is the interpretation of A prime? So I want to get that table right here. So here's what it describes this as. The following table values the number A of automobiles manufactured in the United States. So A prime is typically a rate of change. So when I ask for the context, just kind of throw the rate of change into the context and what that would mean. So A prime of T is the rate of change of automobiles per year. So it would be like the number of automobiles per year, how the production is either increasing or decreasing, what the rate of change is. So I'm not going to write that down, but you guys should be able to write things down like that, especially on the AP test. So estimate A prime of 1971. Okay, so here's 1971. What I'm going to do is I'm going to take the values at 70 and 72 and just do a secant line from those values. So change in A over change in T. So 8.83. So we're doing, let's see, A prime of 1971. So I'm going to do the automobiles in 1972 minus the automobile production in 1970 to get a nice little secant, and then 1972 minus 1970. Okay, so automobile production was 8.83 in 1972 and 6.55 in 1970. 2-year time span. All right, so this would be, what, 2.18 and then over 2, so that would be 1.09, and that would be in millions of automobiles per year. So that's an increase. Obviously, you can see you've got an increase in production. And then A prime of 1974, next it asks us if that appears to be positive or negative. So if we're looking at the table here, 1974, from 1973 to 1974, the production went down. And from 1974 to 1975, again, production went down. So I would say it definitely appears to be negative. Those values are decreasing as you go. And so I would say that rate of change is going to come out to be negative. Again, we can't make assumptions. That's why I asked if it appears to be positive or negative. Okay, 24, I believe, is using that same table. Given the data, which of A through C could be the graph of the derivative? Okay, so let's put this all up here again. So we are hoping for one of these to be the derivatives, but again, which could be, doesn't mean it is. So it looks like we've got a pretty steady increase between 1970 and 1973. Okay, so this appears to be increasing all the way to 73, so this is an option. This is a definite decrease, that's out. And this one increases, but then does a sharp decrease. So I'm thinking that this is probably not it. Let's kind of see if this makes sense here. So then it looks like there's a decrease between 73 and 75. And that's what appears to be happening here. And then there's an increase from 75 to 76. So this seems like a pretty good estimation here. All right, so yeah, we're going to go with A. A would be the derivative. And you could explain all the things that I was just saying, that, you know, the values seem to be increasing. Oh my goodness, I just answered that as if that was a graph of A. Okay, hold on, I need to change my answer. Because the derivatives should either be positive or negative. Okay, let's try that again. From 70 to 73, A is increasing, so A should be positive, like above the x-axis. Okay, so this is out. This is in. This is in. Okay, so, and then the decrease happens somewhere around here, somewhere around 1973. So you can see it dips back below the x-axis somewhere around here. Okay, then it decreases for a little while, decreases maybe till 75, and then it starts increasing again. So my derivative should be negative for a bit, but then it should go back positive. This one's negative for a bit and then goes back positive, whereas this one stays negative the whole time. So it is B. I apologize. I hope that did not confuse you too much. I was originally answering as if that was A, but we should be answering as if it's A prime. I apologize. 29 to 34 is our next segment here. So these are just a whole bunch of derivatives. So we'll write down this function. We're just going to get some practice with power rules, constant multiples, product, quotient, all the good stuff. So y prime, constant multiple rule says the 3 just stays here while I take the derivative of x to the 5th. So 3 stays here. The 5 comes out fronts, and then I subtract 1 from my power to get 4. Minus, here the 7 just stays there. The 2 comes out fronts, subtract 1 from the power, plus, and then 4 is just a constant, so the derivative would just be 0. So let's clean this up. We're going to have 15x to the 4th minus 14x, and then I don't need that 0. Okay, here I start with the constant multiple rule again. The 4 is just going to multiply by whatever my derivative is. Power rule says the negative 3 halves comes out front as my new power, or as my new coefficient, I'm sorry, and then my new power, I subtract 1 from my old power. Okay, let's clean this up. Negative 6x to the negative 5 halves. Okay, this one is just a demonstration of the power rule. The old power, whatever it is, comes out front. Doesn't matter if it's decimal, fraction, irrational, whatever. And then I just subtract 1 from my power to get the new power. Okay, y prime for this one, constant multiple rule says the 4 stays right there while I take the derivative. 2 comes out front as a coefficient, and I subtract 1 to get my new power. Minus, okay here, negative 2 comes out front as my coefficient, and I subtract 1 to get my new power. Clean this up, we get 8x plus 2x to the negative 3rd. Okay, here's a quotient rule with this one. So I want you guys to keep yourselves organized while you're doing product rules and quotient rules. That way you know where all the pieces are. So high, we've got x plus 1. That's the numerator. Low, we have x squared plus 1. That's the denominator. D high, that denotes the derivative of the numerator. So this is linear. Our derivative would just be 1. And then D low is the derivative of the denominator. Derivative of x squared is 2x. Power comes out front. And then plus 0. So just a 2x there. So my derivative, y prime, my rule is low d high, so x squared plus 1, and then just times 1, minus high d low, and then all over low low. Okay, so we want to do a little bit of cleanup, especially in the numerator. So here, this is just x squared plus 1. Here I can distribute the 2x, and I get 2x squared plus 2x. So let's combine like terms. X squared minus 2x squared gives me a negative x squared. Nothing minus 2x, and then 1 minus nothing. And then this, I would not attempt to FOIL that out. Just leave it exactly the way it is. So your derivative will look like that. Okay, we got 34 as well. Okay, 34, we got another quotient rule. Okay, so the numerator is 3t minus 2. Since it's linear, its derivative is just 3. Oops, not d low, just low. The denominator is 4t minus 9. Again, since it's linear, its derivative is just 4. So let's combine all that up in the quotient rule. So y prime, low d high, minus high d low, all over low low. Okay, so let's do some distributing, some combining. So multiply this by 3, multiply this by 4. Okay, so when I subtract up in the numerator, the 12t's will cancel each other out, and I'll have negative 27 minus negative 8. So plus 8 will give me a negative 19. And again, no need to FOIL out or do anything with that denominator. So this would be your derivative. Okay, next we're jumping all the way to 85. 85 has kind of like this set of using generic product rules and sum and difference rules and things like that. So my function here, I've got s of x equals 3f of x minus 2g of x. The AP test loves doing this, like generic derivatives. So it's asking you to find the derivative using the table of values. So s prime, constant multiple rule says the 3 just stays right here while I take the derivative of f. So again, generically, all I'm going to do is write f prime. And then minus, the 2 stays out front while I take the derivative of g. And again, generically, I am just going to write g prime. Okay, so now, when I come off the table, they're asking me for the derivative at x equals 2. So s prime of 2, I'm just going to replace my x's with 2's and then pull the values right off the table. Okay, 3 times. Now f prime of 2 comes right off the table. It's negative 3. Minus 2, and then g prime of 2 also comes right off the table. It's 9. So I have negative 9 minus 18. That leaves me with negative 27. Okay, we're also doing 86 and 87 in that same section. So 86, we've got a new function h of x, and it is f of x times g of x. So this is asking us to do basically a generic product rule. Okay, so the first function is f of x. Its derivative we can generically write as f prime. The second function is g of x, and again we can write its derivative just as g prime. So for h prime, we do 1 d2, so f of x times g prime of x, plus 2 d1, so g of x times f prime of x. So this is just the product rule, like that should look familiar to you. So again, we're specifically looking for the derivative at 2, so I'm going to replace all these values with 2's and then just grab the numbers right off the table. So f of 2 is 5, g prime of 2 is 9, g of 2 is 4, and f prime of 2 is negative 3. So I end up with 45 minus 12, which is 33. Okay, so it's very important to be able to know how to do these generic ones like this. And last one, 87, is a generic quotient rule. Okay, so for r prime, we do low, d high, minus high, d low, and then all over low, low. Okay, so that's the generic quotient rule. I want the derivative at 2. So I'm going to plug the 2 in everywhere. Okay, and then just like before, I can pull those values right off the table. So g of 2 is 4, f prime of 2 is negative 3, minus f of 2 is 5, g prime of 2 is 9, and g of 2 is 4, and I square that. Okay, so I have negative 12 minus 45 over 16, so that gives me a negative 57 over 16. Very nice value. Okay, just a couple more left. So I've got 91. So 91 says find the points on the graph whose tangent line has a slope of 10. So let me write down that equation first. So being able to answer questions like this is super important for the AP test. So we want the tangent line to have a slope of 10. So what we're looking for is we want values of the derivative to be equal to 10. So in order to answer that, I have to find the derivative first. So f prime, derivative here, the 3 comes out front. subtract 1 from the power to get 2, minus 2 comes out front, it's going to multiply by the 3 that was already there, power drops down to 1, plus, so 91 says find the points on the graph whose tangent line has a slope of 10. So let me write down that equation first. So being able to answer questions like this is super important for the AP test. So we want the tangent line to have a slope of 10. So what we're looking for is we want values of the derivative to be equal to 10. So in order to answer that, I have to find the derivative first. So f prime, derivative here, the 3 comes out front, subtract 1 from the power to get 2, minus 2 comes out front, it's going to multiply by the 3 that was already there, power drops down to 1, plus derivative of x is just 1 because it's a linear piece, and the derivative of 4 is 0, so I'm not even going to write that. And I want to set this equal to 10. So clean this up a little bit. I'm going to subtract the 10 from both sides. And then I'm going to solve this by factoring, but I would factor out a 3 first. So divide everything by 3. And then if you divide the right-hand side by 3, it's just still 0. So it's an easy way to reduce down. And then factor this. This multiplies to 3 and adds to negative 2. So I end up with positive 3 and negative 1. And those specific values would have a derivative of 10. So if you plug those back into the derivative, you would get 10 as an answer. All right, just 2 more. We got 95. Okay, so 95 is asking us to find the second derivative. So we'll get a little practice with that. Okay, so in order to find the second derivative, we know we need the first. So 3 comes out front, multiplies by the 12 that was there, subtract 1 from the old power, minus 2 comes out front times the 5, subtract 1 from the old power, plus this is a linear piece, the derivative is just 3. So now we just repeat the process, just take the derivative again. So 2 comes out front times the 36, power drops down to 1, minus derivative of 10x is 10 because it's a linear piece, and 3 is a constant, so its derivative is 0. So that would be your second derivative. All right, and last one is 107. Just going to do this right on here. Okay, so label the graphs f, f prime, and f double prime. Okay, so the answer to this, red right here is your original graph. Okay, so notice it is increasing, stops, and then continues increasing. And if you look at the green function, see how red is always increasing? The green function is always positive. But it goes to 0 at one point, and that's when this slopes off to 0. So increasing towards 0, then increasing away from 0. So this is positive and headed towards 0, then positive and headed away from 0. So red is f, green is f prime, and then the derivative of green, that's just the absolute value function. Over here, it's just a linear piece with a slope of negative 1. That's that down here. And over here, it's just a linear piece with a slope of positive 1. And that's this piece right here. So red is f, green is f prime, blue is f double prime. Okay, and now let's look at the behavior on this one. We've got some crazy things going here. None of these are quite like cubic or quadratic or whatever. So let's look at some features. Let's look at this green one because it's got kind of more dramatic behavior than the other ones. Notice that this has a max right here and the red one has a 0. And notice this has a min right here and the red one has a 0. Okay, so if we check the behavior, this is increasing and the red one's positive. This is decreasing and the red one's negative. This is increasing and the red one's positive. So we know for sure that red is the derivative of green. Let's see where blue fits in. All right, so notice here that this is just negative but not doing very much exciting, and then it's 0, and then it's positive. If you look at the red one is decreasing and pretty steadily. That nearly looks linear, and notice that the blue one nearly looks constant. And then it sort of slopes off. When this one has a min, the blue has a 0. So that means that green is f, red is f prime, and blue is f double prime. Okay, notice there was nothing on here that had anything trig. I will explain why. If you look at all of these problems right here, Anything that involved trig also had composite functions, and that's not something that we're capable of doing. So please, please, please make sure that you are looking over all of your trig derivatives as well. And we have that rate of change stuff too that we did in section 3.4. So look over that particle motion worksheet and make sure you're comfortable with all that.